Welcome back to Mr. Hassan's Math channel. This is now question number 6 from the International A-Level Edexcel Pure Mathematics P1 June/October 2020 paper. And here we have a question about straight line graphs. 6 part A tells us to find the gradient of the line AB which passes through the point -411 and the point 8, 2, sorry. So the point A has coordinates -411 and the point B has coordinates 8, 2, and we want to find the gradient of the line AB. Well, you'd have to take away the y coordinates from each other, so you're going to have 11 minus 2 and divide that by the difference between the x coordinates, which is -4 minus 8. Okay, that's like the rise over the run. That's going to give you 11 minus 2, which is 9, and -4 minus 8, which is -12, which is -3/4. So the gradient of the line AB is equal to -3/4, and that's the answer to part A. Okay, now part B. Let me just write down the coordinates here. -411, and we got B as 8, 2. Okay, just write them down there. Now it says the point M is the midpoint of AB. The line L passes through M and is perpendicular to AB. Find the equation for L, giving your answer in the form Px plus Qy plus R equals 0, where P, Q, and R are integers to be found. Okay, so basically they're asking us to find the perpendicular bisector of AB. It's a line which is perpendicular to AB and passes through its midpoint. So we need to find the midpoint of AB. Now the midpoint of AB is going to be given by the sum of the x coordinates, so -4 plus 8 divided by 2. That's for the x coordinate of the midpoint, and for the y coordinate it's going to be the sum of the y coordinates, so it's 11 plus 2 over 2. So remember, for midpoint it's the sum, not the difference of the coordinates. That's a mistake that a lot of people make, because gradient is given by the difference of the y coordinate over the difference of the x coordinate. Even the length of a line segment is given by the difference between the x coordinates squared plus the difference between the y coordinates squared under the square root. So a lot of people mix it up with the midpoint with the other two. Now the midpoint, you add the x coordinates together and divide by 2, and you add the y coordinates together and divide by 2, because you're finding the average of the x coordinates and the average of the y coordinates when you're finding the midpoint. So we can say the midpoint is therefore going to be, that's -4 plus 8, which is 4, divided by 2, which is 2, and 11 plus 2, which is 13, divided by 2, which I'll leave as a fraction, 13 over 2. Okay, that's the midpoint of the line, and we said they told us it's perpendicular to the line, so we can say it's perpendicular to AB. It's perpendicular to AB, so its gradient is going to be the negative reciprocal of the gradient of AB. So we know the gradient of our line, okay, is perpendicular to the gradient of the line AB. So therefore the gradient of our line is a negative reciprocal. So instead of being -3/4, you're going to change the sign, so it's going to be positive, and you're going to write the reciprocal of 3/4, which is 4/3. So the gradient of our line L is 4/3. So we can say that the gradient of our line is 4/3. So we can now say that our equation, if we want to put it in this form, y minus y1 equals m times x minus x1. So y minus the y coordinate, which is 13/2, equals m, which is 4/3, times x minus the x coordinate, which is 2. Okay, now I want to express this in the form like here, where I need p, q, and r to be integers. So what I'm going to do is I see I've got a fraction on this side of 2, a fraction on that side with a denominator on this side of 2, a denominator on that side which has a 3. So if I multiply both sides by 6, what's going to happen is I'll get rid of the fraction. So this will be 6y minus, now 6 times 13/2. There's 2 and the 6 cancel to give you a 3. 3 times 13 is 39. And I'm going to have 4/3 times 6. Now 4 over 3 times 6, the 3 and the 6 cancel to give you a 2. 2 times 4 is 8, so this will be 8 times x minus 2. So I got 6y minus 39 equals 8x minus 16. So I want to put it in this form. What I'm going to do is I'm going to write everything on the side where x is positive, just to make life, it's normally better to do that. So I'm going to have 0 on this side. I've got to take away 6y from both sides, and I've got to add 39 to both sides. So I've got minus 16 plus 39. So that's like 39 minus 16, which gives me 23. So it's going to be plus 23. So I end up with 8x minus 6y plus 23 equals 0. That's the equation of the line which passes through the midpoint of AB and is perpendicular to AB. Then basically the perpendicular bisector of AB. So there's the answer for part B of this question. Okay, now on to part C. Okay, so it says the point C, this is stuff from the first part of the question we might need, but it says the point C lies on the line L such that the area of triangle ABC is 37.5 square units. Find the two possible pairs of coordinates of the point C. Okay, so now in this type of question where they tell you about triangles or shapes, a very useful thing for you to do would be to make a little sketch. It doesn't have to be an accurate diagram, but a sketch of what we're given. Okay, and that will help us to work out what we need to work out. It's very important for us to make sketches in this type of questions to get a picture of what's going on. So what I'm going to do is I'm going to draw like a pair of axes here. I'm going to draw my x-axis. Is that straight? I think so. And a y-axis. Well, that's my y-axis, my x-axis. And I'm just going to just mark these points A and B. So minus 411. So minus 411, I'll just put it like somewhere over here. And you're going to have the coordinates B, 8, 2. That's somewhere over here. So let's say that's A and let's say that's B. Okay. So that's minus 4 and that's 8 and that's 2 and that's 11. Okay. And then M is the midpoint of AB, and we worked out the coordinates of M, which was 2 and 6.5, basically 13 over 2. All right. So let me just confirm that, make sure. Yep, 2 and 13 over 2, so it was somewhere over here. Let's say the midpoint was there. That's 2 and 6.5. That's where M is. Okay, and then you had a line. So that's the line AB. So I'll just draw a line through those two. That's the line AB. Okay, that's the line AB. Okay, and there's the midpoint of that line. Okay, then you had another point that passes through the midpoint and is perpendicular, another line, and that's the line L. Okay, which we worked out. Okay, it's the line L, something like this. Okay. All right, now. I don't need that there. This is not accurate, so I'm not going to assume anything that passes through any place. I can work out where it does, but I don't really need that. Okay, so now the equation of that line that we just found now was, I think, 8x minus 6y plus 23 equals 0. Let me just confirm that to make sure. 8x minus 6y plus 23 equals 0. That's correct. Okay, so that's line L. And this is the line that goes through A and B. And we know that they're perpendicular. Okay, now it says there's a point C which lies along L somewhere, such that the area of triangle ABC is 37.5 square units. Okay, so there's a point C somewhere. Let's say it's over here. Okay. And I know that the area of this triangle here is 37.5 square units. Okay, but there's another point where C could be, which is going to be somewhere over here. Okay, somewhere over here. Okay, somewhere over here, let's say so it has to be the same distance. Okay, let's draw it like this. Okay, so somewhere in this area here, we don't know exactly where. It could be in positive, negative side. We have to work out where it is exactly. But basically, has to be the same distance. This has to be the same distance as this. Okay, because you know, the area of this triangle is the same as the area of this triangle, and you can see that if this is a right angle, this is like the height of the triangle. Okay, so we know the area of ABC. So let me call this C1 and call this C2. Okay, so we know the area of triangle ABC1 is equal to the area of triangle A. The area of triangle ABC1 is equal to the area of triangle ABC2, which is 37.5 units squared. Okay, so we know that. That's what we know. All right, so what I can do here is I can work out what this distance here should be. This is like the height of the triangle. Okay, because we know that the area of a triangle is a half times the base times the vertical height. So I know I can work out what the base is of the triangle. Okay, I can work out what the base is of this triangle. What I need to do is to work out the height of this triangle. Okay, so what I can do is, let's work out what the base is first. So the base of the triangle is equal to the distance between A and B, which we can find using the distance formula, where we take the coordinates of A and B and we subtract the x coordinates. So you're going to have -4 minus 8 squared, and we subtract the y coordinates, which is going to be 11 minus 2 squared. That gives me the square root of, that's -12 squared, which is 144, plus, and you're going to have 9 squared, which is 81. So that's going to give me the square root of 225. I think that gives us an exact value. Let's just check. The square root of, let's just make sure, 144 plus 81. Yeah, it gives you 15. Okay, so I can see that the base of the triangle is 15. Okay, so therefore we can use that. We can say that the base of the triangle is 15. Therefore the area is a half times the base times the height. So we know 37.5 equals a base, which is 15, times the height divided by 2. So the height is going to be 2 times 37.5 over 15. Okay, which gives us, so we have 2 times 37.5 divided by 15, which gives us 5. Okay, so we know that the height of the triangle is 5 units. So I know that from M to C1 is the same as M to C2, which is 5 units. So that's 5 units here and 5 units there. So we could do this in a number of ways. Okay, there's a couple of ways we could do this answer. One of the ways is more complicated, I guess, but you could think of this as, if that is 5 centimeters and that is 5 centimeters, then we could actually draw a circle, okay, with M as the center of the circle, and those 2 points C1 and C2 would be points on the circle. And we could say, okay, where the line L intersects with this circle will tell us the coordinates of C1 and C2. That's one way of doing it. So we can say, okay, the equation of this circle is going to be given by, now this is something which actually is out of the scope of P1. This comes in P2, so I'm not going to go through this, because I'm assuming that some students are doing this who haven't studied the equation of circles, which come in P2. So really the only way for those students, I mean, if you did it and you knew about the equations of circles, like if you did the P1 exam in June when you finished, you know, you already did P2, then it's no problem. You could use the equation of a circle, although it's more complicated in this particular example. There's an easy way of doing it. But that's one way of doing it. But I'm thinking about it again. I won't go through that because I don't think it's suitable for me to go through something from P2 in a P1 exam. Okay, but if you did know how to use circles, you could find the equation of the circle using the center and the radius, which we know is 5, and you could solve simultaneously the equation of the circle and the equation of the line L, which we know, and you could therefore find the point C1 and C2. But that's actually more complicated. Now, I know the coordinates of M are 2 and 6.5. Okay, and I also know that the gradient of the line L, is equal to 4 over 3. Okay, if we just make sure from here, it's 4 over 3, exactly, yeah. So we worked that already. Now that should help us in a little way, because I know that the length of the line from M to C and from M to C2, C1 and C2 is 5. That's 5 units. So if you think about it, the gradient is the rise over the run. So if you think about this, that's the rise and that's the run. It makes like a right angle triangle. Okay, it makes like a right angle triangle. Okay, the rise over the run. So if the gradient is 4 over 3, then this is going to be 4 and this is going to be 3. And you can see that that's 5 units, because you have a 3, 4, 5 triangle. Okay, so that's 3, that's 4, and that's 3, and that's 5. So knowing that that's a 4 and a 3, and you know that the distance between M and C1 has to be 5, it should trigger you know, the 3, 4, 5 triangle in your brain. Okay, so we know that that's 4 and that's 3. Okay, so we can say that C1, its coordinates must be, if you think about the coordinates of M, 2, 6.5, the coordinates of C1, the x coordinate has to be 3 more than 2, which is 5, and the y coordinate has to be 4 more than the y coordinate of M, which is going to be 10.5. And we can say for C2, we can see that the same thing applies. You're going to have rise and you're going to have run. Okay, so we can see that the x coordinate has to be 3 less than M. So it's 3 less than 2, which is -1. And it has to be, this one has to, remember this is 4 and this is 3, it has to be 4 less than 6.5, which is 2.5. So we can see that our coordinates of the point C, one of the coordinates is -1 and, what was it, -1 and 2.5. That was actually C2. And C1, the coordinates, as we said, we called it C1, 5 and 10.5. Okay, that's like a nice, easy way of working that out. This is actually quite a tough question in terms of working that out. But you're spotting the fact that you have a 3, 4, 5 triangle there, and that distance, if that distance has to be 5, and the rise and the run is like makes a right angle triangle with it, then that must be 4 more than the y value and 3 more than the x value, and this must be 3 less than the x value and 4 less than the y value for the point M. Okay, so that's one way of doing it, which is actually the quickest way. Okay, there are other ways of doing this, but then most of them will probably be more long-winded than this. As I said, one of the ways is by using the equation of a circle, because C1 and C2 are points on the circumference of the circle. They're both the same distance away from M. So you could take the M as a center of the circle and 5 as a radius of the circle, and find the equation of the circle and find when it intersects the line L. But as I said, that's from P2. So I can't really think of any other algebraic type of method apart from using the equation of the circle, which is not part of P1. So I guess, unless something's escaping me, that this is really the only way of dealing with such a question. And it's because we know the gradient, we know this distance has to be 5, okay, and we know the gradient of the line is 4 over 3, so that's, if that's 4 and that's 3, this must be 5. So it kind of works out nicely in this particular question, because the gradient is 4, the gradient is 4 over 3, so you have a 3, 4, 5 triangle. Okay, there might be some other method dealing with the fact that this must be these two intersect at right angles, so this must be a rhombus. So all these lines are equal in size. There might be some other method that we could think of, but it's going to be way more long-winded than this way. But I'm sure there is another method we could use as well to find this maybe more algebraic type of method. But the only one I can think of right now is the circle. That, you know, if you have a circle, that C1 and C2 will be points on the circle, and the circle have a center M and a radius of 5, and we can work out the equation of the circle using that, and we know the equation of the line L, and we can find where the line L and the circle intersect. But again, as I said, that's outside of the scope of this P1 syllabus, so I won't go through that now. Okay, so thank you for watching, and I hope you understood everything fine. Other questions which are related to straight line graphs will be found in this playlist over here, straight line graphs from P1, and you'll find other questions from this particular paper, which is the October 2020 paper of P1, which will be found in this playlist over here. You can subscribe to my channel by clicking on this icon, and other P1 papers that might interest you will be found by clicking on this card at the top. Thank you for watching.